Welcome to the SVG Virtual Science Classroom. Today, we'll be doing chemistry. My name is Juanita King, and I will be your teacher for today. We will be looking at how to write chemical formulae. I will be sharing with you 6 tips that will help you to write chemical formulae. We will be writing chemical formulae for ionic compounds. Ionic compounds are composed of cations and anions. Cations are positively charged ions, and anions are negatively charged ions. When writing chemical formulae, here is tip number 1. Always write the cations first. Let's take a look at some cations. You have the sodium ion. Notice it has a positive charge. The calcium ion also has a positive charge. The ammonium ion also has a positive charge. So, when you are writing chemical formulae, always place the cation portion first. There is one exception to this rule, and that is when you are writing the chemical formulae for compounds which are derived from organic substances. The second tip is 1 is understood. There is no need to write the number 1. 1 is understood. So for example, remember, we don't write 1. Take a look at this ion. It's the sodium ion. This means that sodium has a single positive charge, but there's no need to write the number 1. We understand that there's a 1 in this ion. So when we write the chemical formula using sodium ion, there's no need to write number 1. Here's an example of what I mean. Right in your kitchen, you will find some salt. Salt is also known as sodium chloride. What is the chemical formula of sodium chloride? Remember tip number 1, write the cation first. So, sodium chloride is made up of the sodium cation, and we write that first, and the chloride ion, Cl-. Always place the positively charged ion first. Now take a look. Let's apply tip number 2. Tip number 2 says we don't write 1. So if we are writing the formula for sodium chloride, the formula would be NaCl. There is no need to write the number 1. Here is another example where there's no need to write the number 1. Let's write the chemical formula for potassium fluoride. Potassium, its ion is K+. The fluoride ion is F-. Both of these charges would have a number 1. But there's no need to write the number 1. So the formula for potassium fluoride is KF. Here is tip number 3. When the charges carry the same number, the numbers can cancel each other out and become like 1. Here's an example. Let's write the formula for calcium oxide. Calcium, its ion is Ca2+. The oxide ion is O2-. That's a capital O. So what is the formula of calcium oxide? Based on our tip, remember, both of these charges have the same number. Both of them have the number 2. So we can simplify the formula. So instead of writing Ca2O2, we can simplify that formula to Ca1O1. But we do not write the number 1. So the formula is CaO. Let's take another example. Aluminum nitride. The aluminium ion is Al3+. The nitride ion is N3-. Both of these ions have the same number on their charges, the number 3. These trees can be divided by 3 to simplify. So they become 1s. So the formula for aluminum nitride is Aln. Here now is tip number 4. I call it the swap and drop method, where you swap the numbers on the charges and drop them into place. Swap and drop. Here's an example. Let's write the formula of aluminum oxide. Do you remember what the aluminum ion is? It is Al3+. And the oxide ion is O2-. Now take a look. They both have different numbers on their charges. This one has a 3 and this one has a 2. Here's what we're going to do to write the formula. We are going to swap the numbers and drop them into place. So we're going to swap the 3 and the 2 and then drop them into place. So the formula of aluminum oxide is Al swap the number, so we get 2 over here, O, and swap the number 3 and drop it into place. Now what do I mean by drop it into place? Notice that the numbers that are written here are lower. This is not correct. Neither is this. So we want you to write those numbers as subscripts. Subscripts, meaning that they are dropped. Here is another example using the swap and drop method. Let's write the formula of potassium oxide. Potassium is K plus, and the oxide ion is O2 minus. Always remember to write a capital O for oxides. Now notice, the potassium has a single charge. The oxide ion has a 2 minus charge. We are going to swap the numbers and then drop them into place. Swap and drop. The only thing we swap is the number. So the 2 goes to the potassium and the 1 goes to the oxide. But we don't write 1 because 1 is understood. So the formula of potassium oxide is K2O. Here now is the next tip. When you are dealing with polyatomic ions or radicals, you place them in brackets if they are receiving a number greater than 1. Place polyatomic ions or radicals into brackets when receiving a number greater than 1. Let's have an example. Let's write the formula of ammonium sulfide. Ammonium sulfide. The ammonium ion is NH4+. This is a polyatomic ion because it is made up of many atoms. So polyatomic, many atoms. Let's take a look. In the ammonium ion, we have 1 nitrogen, and bonded to that nitrogen are 4 hydrogens. These are all bonded together, so they exist as one entity with a positive charge. So whenever the nitrogen in ammonia moves, the hydrogens in the ammonia move with it. They come as one package. So we cannot separate them. And whatever happens to the nitrogen must also happen to the 4 hydrogens. The sulfide ion is S2-. Let's write the formula for ammonium sulfide. Swap the numbers on the charges and drop them into place. The ammonium ion will be receiving the number 2. 2 is greater than 1. So that means we must place the ammonium ion into brackets and drop the 2 outside of the brackets. The sulfide ion would be receiving the number 1. So we just write S. No need to write 1. 1 is understood. So the formula of ammonium sulfide is, open brackets, NH4, close brackets, 2S. Here's another example of writing formulae involving polyatomic ions. Let's write the formula of calcium sulfate. The calcium ion is Ca2+. The sulfate ion is SO4 2-. That's a capital O. Now take a look at this. Both of these ions have the same number. Which rule applies now? They both have the same number, so we can divide each number by 2 to simplify it. If we divide each number here by 2, then what is the formula of calcium sulfate? CaSO4. Do we need the brackets now? No, because 1 is understood. So we only have one sulfate, so there is no need to write brackets. Let's take another look at writing a chemical formula that has polyatomic ions receiving a number greater than 1. Here's calcium phosphate. Calcium phosphate is found as an anti-caking agent in some powdered substances around your home. Let's write its chemical formula. Calcium again is Ca2+, and the phosphate ion is PO4, 3-. Which one of these is the polyatomic ion? The phosphate. It's made up of 1 phosphorus and 4 oxygen atoms, and together they exist together as one entity with a 3- charge. Let's write the formula. We swap the numbers on the charges and drop them into place. So the calcium will be getting the number 3. The phosphate would be receiving the number 2. 2 is greater than 1. So we need to place the ion PO4 in brackets and drop the 2 outside of the brackets. So the formula of calcium phosphate is Ca3, open brackets, PO4, close brackets, 2. And here is the final tip, and the most important one. Learn your ions. As you can see, our whole process of writing chemical formulae involved knowing the ions. If you do not know your ions, you will struggle to write chemical formulae. Please learn your ions. Start by learning at least 3 ions a day. You must learn your ions. So we have just done 6 tips which will help you in writing chemical formulae. Thank you for viewing the SVG Virtual Science Classroom. Bye.